Hello programmers, in this video we're going to discuss about the repartition and coalesce in Apache Spark with Java. Let's see what is repartition and coalesce and its difference. Both are very expensive operations as they shuffle the data across many partitions, hence try to minimize the usage as much as possible. By default, Spark shuffling partition size is 200, and if you want to change, we can change in the configuration and the key called spark.sql.shuffle.partitions. Fine. Let's see the major difference between repartition and coalesce. With the help of the repartition, we can able to increase or decrease the partition, but in a coalesce, only we can able to decrease the number of partitions. In a repartition, the partition data are equal in size, but in a coalesce, the partition data are unequal in size. Now, with respect to the performance, repartition is less performance when we compare with the coalesce, but coalesce is better performance when we compare with the repartition. And final important thing, so unequal size partitions are generally slower to work when we compare with the equal size of partitions. Fine, let's get into the program. So here you can see this is a simple Java class. It's a simple main method. Here it just turn off the Spark info logs. Here it just creating the Spark session object with the master is local array of I, just to demonstrate the difference between the repartition and coalesce. Here I just creating the list of integer and it's a value range from 0 to 40. Here I just converting the list of integer to data set, and the header is called int values. Here it displaying the same, and here I just finding the number of partitions before we start use the repartition and coalesce. Fine, let's start the repartition. So with the help of the repartition we can able to increase or decrease. Now I'm going to increase and going to assign some value, and next I'm going to find how many partitions available after we called the repartition function, and I'm going to calculate, and similarly I'm going to do for coalesce as well. So with the help of the coalesce we can able to only decrease the partitions. Now I'm going to decrease to 4, and I'm going to calculate the number of partitions as well. Fine, I'm just going to run the program. Let's see the result. Fine, it's got completed, and you can see before we start the repartition coalesce, the initial size is 5 because we define the master is a 5 cores, and here it's a repartition call is 8. Here I had defined the 8, and the coalesce is before we can see the coalesce. And so if you want to calculate the number of partitions, we can go with the get number of partitions, or otherwise we can go with the partitions dot length. So both will return the same value only. Okay, just going to run the program. Yeah, you can see both the coalesce value is 4 and here it's a 4. Fine, and next I'm going to calculate uh, how many values are available in each and every partitions. Let's start with the repartition. Partition dot going to create the new column with the name of, so each and every partition should be have some unique ID. So here I'm going to display the partition ID, the header called the column name called repartition id, and to assign the unique number we have to call spark dot partition id, which is available in the functions, and we need to do the group by, and we need to do the aggregate functions of count. We need to calculate the how many records, so we need to do the count. Here you have to define the source column value, group by partition column header dot show, and we can do some order bit so that we can see in order. Yes, and the similar thing I'm going to repeat for coalesce as well. And I'm going to name it as, going to rename the column header, nothing else, just to see the difference between the coalesce id and the repartition id. Going to run the program. Let's see the result. Fine, it's got completed. And so after we call the repartition, it's have 8 number of partitions available, and all the partitions having equal number of values. So you can see each and every partition having 5 number of values. Let's see for coalesce. So it is reduced to 4. So it should be 4 partition 0 to 3, and you can see the each and every partition doesn't have the equal number of values. So when we call the coalesce function, the data will move to the nearest partition. So hence it's more fast when we compare with the repartition and coalesce. And fine, next I'm going to write the data in some file, and dot write dot save, and here we need to define the file path where we are going to save. So here I'm going to define the folder name, so it will create automatically when we run the program. And here I'm not defined the file format, so if we not define the file format, Spark will create automatically write the data in snappy compressed Parquet file format. And I'm going to repeat the same for coalesce as well. And here I'm going to define the file format as CSV. So just to demonstrate how it's work, nothing else. I'm going to run the program. Let's see the result. Fine, it's got completed. First start with the repartition ID. So here you can see the files are in snappy compressed Parquet format. Here we defined 8, so it should be 8 files. 1, 2, 3, 4, 5, 6, 7, 8. And for the coalesce, it should be 4 because we defined 4. 1, 2, 3, 4. And the file format is CSV because here we defined the CSV. Okay. That's all about repartition and coalesce in Apache Spark with the Java. If you have doubt or clarification or any suggestion, please share in the comment section. Thanks for watching.